Hello everyone, I am Maruthi HC and my co-author is Dr. Poornima Swami. I am working as assistant professor in Government Engineering College, Kushalnagar, and my co-author as well as my guide, she is working in BMS College of Engineering as associate professor. My paper title is fuzzy based energy efficient cluster head selection with balanced clusters formation in wireless sensor networks. I'm going to present this paper. We will discuss about this. So this is the algorithm we have developed, that is FEACH BCF, fuzzy based energy efficient cluster head selection with balanced cluster formation. First we will look at the typical clustered WSN model. So here in this WSN model we have several clusters, and each of the cluster is having cluster head, and we have member nodes. So member nodes belong to that particular cluster and they will transmit their data to the cluster head. Cluster head in turn that will forward the data to the base station and we can access at the message center. So that is about the simple clustered model. So the protocol leech, that is one of the prominent protocols in the clustering technique. So in this leech protocol, every round sensor nodes will compete to become cluster head, and whichever the cluster, whichever the sensor node that wins, so that designated node assumes the role of the cluster head for that particular round, and it will announce as I am the cluster head, and the nearby sensor nodes, those will connect to the chosen cluster head based on the signal strength. But what happens in leech is the number of nodes in each cluster is not the same, it is unequal. The drawback is, one of the drawback, that is small sized clusters will have more number of time slots in the data transmission phase, and subsequently they will consume more energy compared to the large sized clusters, because the member nodes of that small sized cluster heads clusters need to transmit their data more often compared to the larger clusters. There will be more time slots available for the smaller clusters compared to the larger cluster. Next, the modification to make the clusters balanced. So one of the technique that was introduced by Paul, that is a balanced cluster size formation, that is the BCF approach. In this BCF approach, they have used two steps. One is the initial cluster formation and the next is the rescue phase. So here they have defined the limit to each cluster, how many number of member nodes that are allowed per cluster. So that is the threshold cluster. So that is the maximum number of member nodes allowed per cluster. Uh, After the initial cluster formation, there may be unclustered nodes those unclustered nodes, those will connect to the cluster head that is within a distance equal to or less than the threshold distance. If it comes within that distance and that cluster have member nodes fewer than the threshold of that particular clusters, those unclustered nodes that will join to that particular cluster. So, but the drawback of this is these clusters formed by BCF, they will overlap in nature. The cluster will become overlap, and the clusters those will deplete energy quick. And the modification to that BCF by taking the concept of the BCF. So Jasprit Singh have introduced low energy adaptive clustering hierarchy uniform size cluster approach, that is the Leach USC approach. Here also we have two stages. One is the cluster formation stage and another is the refurbishment phase. Uh, they have used the leach technique to form the clusters, and the clusters those are created by the leach technique will have unequal number of member nodes, and here also we use the cluster threshold, that is maximum number of member nodes allowed per cluster. So if there are excess number of member nodes that are present in a cluster that is formed by the leach protocol, so the excess numbers those of member nodes will be assigned to the next best cluster based on the cluster head distance of the neighboring cluster from this particular sensor node, and it will get the membership of that particular cluster of the next best cluster. So here creating uniform clusters based on location of the cluster head, after each round that will increases the computation complexity, and we need to recluster the network in every round, so it will increases the energy consumption. So problem statement is energy efficiency we are trying to achieve because it is very crucial while designing the wireless sensor network, and conventional leach technique that will select the cluster head in each round, each sensor nodes in every round compete for to become cluster head, so which will not guarantee higher energy efficiency. And as we discussed already, there will be size of the cluster, smaller cluster and the larger clusters. So smaller clusters, those will consume more energy compared to the larger cluster. So to resolve all these issues, we have introduced Fitch BCF, our algorithm. So that will achieve balanced clusters and reduced intra-cluster communication distance, and also we are going to use the efficient cluster head selection based on the fuzzy logic. So in the proposed work we have four objectives: to generate clusters of uniform size, to reduce intra-cluster distance, to employ an efficient cluster head selection method, and finally our aim is to increase the network lifetime. So we use K-means algorithm to form the clusters, and we use obviously centroids. But the clusters created by K-means algorithm will have non-uniform sized clusters. So we, inspired by the Leach USC protocol or algorithm, to assign the excess member nodes from a larger cluster to smaller cluster by considering the distance between the next best centroids from the excess sensor node. So by this method, balanced clusters created by this method, the cluster remains the same until the end of the network lifetime. We are not reclustering the network. So after making the uniform sized clusters, so we are going to choose the cluster heads based on the fuzzy logic approach. For that we use residual energy and centrality as parameter. So we can see here after k-means algorithm, so here we have 100 sensor nodes and we created 10 clusters, and this figure A that will shows the geographical distribution of the sensor nodes, and by using the k-means algorithm, so we have created the cluster, and each cluster is having different size, different member nodes per cluster. For example, cluster 1 is having 10 member nodes, cluster 2 is having 14, cluster 9 is having 19 member nodes. The size of the clusters are different. So to make the cluster size equal, oh, in the third figure, figure C, so we are going to sort the clusters in descending order. For example, ninth is consisting of 19 member nodes, that is placed first, and then second cluster, and then third cluster, and then first cluster. Finally, we have 10th cluster, it is having only 5 member nodes. We are arranging the clusters in descending order. After that, we check that whether the threshold value of the cluster, whether it is exceeded. So the exceeded excess member nodes of that particular cluster, that will be those sensor nodes membership that will be transferred to the nearby cluster based on the centroid distance. So after that, so 100 sensor nodes, each cluster will have equal number of member nodes. This is how, and after equal number of member nodes per cluster, we are going to use the fuzzy rules to select the cluster head. So the parameter we will use is residual energy as well as centrality, and this local qualification that will tells us that which sensor node or which member node will have the higher probability to become a cluster head. For example, residual energy of the sensor node is very high, and the centrality is low, so it is having more chance to become cluster head. In the same way, residual energy is low and the centrality is high, it is having very low chance of becoming a cluster head. So coming to the actual simulation, we have used the network size, that is 50 cross 50 meter square, and total number of sensor nodes are 50, and we assumed initial energy of each node is 2 joules, and size of data packet is 4000 bits, and this is the sync position, and we have considered both the free space model as the multipath model. The values are here, and the data aggregation energy and required energy to run circuitry, that is the 50 nanojoules per bit, and the percentage of the cluster head is 5. So we have used total 50 sensor nodes. 5% of that is uh, we get approximately 3 clusters, 5% of 50. So here, after actual simulation, so this is the cluster structure using k-means algorithm. So that is before the load balancing. So after that, as we discussed in the previous slides, uh, excess nodes that will be moved to the neighboring clusters based on the that particular access node's location to uh, the nearest centroid. So after doing that, uh, so cluster 1 is having 16 member nodes, cluster 2 is having 17, cluster 3 is having 17. So if we use 51 sensor nodes, so then each clusters will have 17 per cluster size. After running this simulation, so we came to know that what is the total intra-cluster distance for each of the technique, leech BCF and leech ESC, and our proposed technique Feach BCF. So consider this in the first iteration, cluster size of first cluster, that is 20, and the size of the cluster 2 is 9, size of the cluster 3 is 21, and the intra-cluster distance, total intra-cluster distance is 695. And for the BCF it is 892, and the leech USC it is 758, and our proposed algorithm will have 608. So it is less compared to any other technique. We have done 3 iterations. In every cases, our approach that gives lesser total intra-cluster distance. Lesser distance, obviously, so the energy to transmit that particular data, so it consumes lesser energy. So we have run for several rounds our simulation, and the network lifetime, that is for FND, first node depth, off of the node and last node. So the values that came, it is for the FND leech is 540, BCF is 612, leech ESC is 718, and Feach BCF, that is 7163 rounds. 7163 rounds. So all the nodes are operational up to 7162 rounds in our proposed technique. So uh, next HND also, it is a 9054 for last node depth also, that is 9130. So it by our technique, the energy efficiency that increased in lot much higher compared to the previous technique. So coming to the conclusion, the Feach BCF technique that employs k-means algorithm to establish the initial clusters. And the centroids of each initial clusters are used to attain loaded balancing, and fuzzy logic that is used for the selection of optimal cluster heads. The simulation results indicate that the proposed approach surpasses leech, BCF, and leech ESC in terms of network longevity, and establishes well-balanced clusters with reduced intra-cluster distance and an efficient cluster head selection technique. Thank you.